So we follow these formats, and remember, A is whichever number is larger. That determines the major axis, because on an add, it's commutative, so you can put X or Y first. So don't go always by who's first. Most of the time they put the X first, but they can put a Y first. And you guys tell me if you have any questions. Your foci fall inside your ellipsis and equal distance from the center. Equal distance from the center. Again, your endpoints that are critical are your vertices. This is off your major axis. And your co-vertices, these are off your minor axis. And your center, of course, is important to find. Then I think we just switched it around. And sometimes between 4 and 5, it's a little bit tough to make it look like an ellipse. It almost looks like a circle. There's not a big difference between those because we're sketching. But as long as you label everything, you know what's going on. And use this little formula. Everybody's comfortable with this to find C? Because you want your foci to fall inside, so you subtract them. And you can get radicals in this as well. And with the radicals, if you want to just over here say 0 plus or minus radical 5, I'm good with that too. There's nothing else to do with that. If you want to use the formulas, not use the formulas, whichever. If you find it easier just to go by the graph and count your spaces left and right and up and down, it's so much easier. Okay, I guess you guys are good with this. So my ellipses look horrible.
Mine do too, and I'm drawing mine on paper.
And I have to use my computer, which is a little tougher too.
So I'm a little worse.
I have no art skill in me at all. Are we good with this? When you get down to these, you do have to resolve those. Don't leave them there like that. Just if it's a radical, you can leave the radicals. Then we had to complete the square guy here. There was a complete the square. Get your x's together, get your y's together, get your constant on the other side. You should never come out with a negative. Oh, I shouldn't say that. We'll do hyperbolas next, so yeah, we could have negatives. But for our ellipses, we won't have any negatives for our ellipses. Hyperbolas, yes, but not ellipses. And remember the sketch, just remember to just watch where your endpoints are going. Good. No questions? Another complete square.
I had difficulty with this one here.
Completing the square?
No, when you had to divide by 25.
Because did you bring the 16 down?
Well, I just kind of got to that point and then stopped.
I stopped there too.
Right. Well, because you can't leave anything in front of this, so you have to reduce it down.
But I just wasn't sure if you could have a fraction in the denominator, so I just stopped because I wasn't sure.
We don't leave it there. If you were going to write the equation, you excuse me, you would write the equation like this. However, to find A and B, these coefficients have to be 1. They have to be by themselves. That's why we divide by 1, make this 1, and these have to be 1. So just to do this part, to get your A and your B, this is your A squared, this is your B squared. Just to find A and B, you bring that down. But if you're going to leave the equation, you would leave it like this, without the fraction in it.
Okay.
But to work out the A and B, you have to bring it down. And this is larger than the 1, so it was nice they gave you a perfect square for that. And it kind of puts fractions into your foci as well. a little bit different to look at. Don't forget, if it was a circle, you'd see those the same. 5 and 5, 3 and 3. You'd see those the same. What makes it an ellipse is the x squared, y squared, but the coefficients are different. And then the last one was another complete the square. You had a little bit of a fraction in your center, which changes all your vertices. They look weird, but they're really easy formulas to work. You're going to follow your basic equation, but remember, what happens is you have to figure out where is the A and where is the B. This can change depending on who's the major axis. So, and then if you offset your center, K always goes with the Y, even if they put the Y first. Did you have any homeworks where they put the Y first? No? Okay, so what you want to do is sketch and figure out your values of A, B, and C. And C, sometimes you won't need C, but sometimes you're given C and you have to find A and B because of C. So work with what they give you. It has vertices of 0 plus or minus 8. So 0 plus 8, 0 minus 8. If these are the vertices, which is the major axis?
Y.
The y-axis. So you're going to start with your A under your Y. Okay. And what would the value of A be? Just A. The value from here to here, from your center.
Oh, I thought we were doing A squared.
What would your center be?
0, 0.
0, 0. So the center of 0, 0. So what's the distance from the center to the vertex? To one vertex point. 8.
I
So,
thought we were doing A squared.
yeah, just give me A right now. We'll plug it in there. And your foci is from 0, 4, 0, negative 4. So you know you've got an ellipse that looks like this. It's oblong. And you know you have your foci. So your foci gives you the distance of C. What's the distance of C? 4. So I've got a lot going on, and as Ashley said, this is going to be 64, 8 squared. All I have to do is find B. And those are where my co-vertices are. So in this case, you just need to know your little formula. And now you can find C. A B, given C. Okay, to subtract 64. What is that equal to? Negative 48. Divided by a negative 1. Now, because you're making an equation, and you're going to have to square whatever B is, this is B squared. You can find B by taking the square root, and then you can absolutely break this down into 16 times 3. But you don't really have to do this, because when you plug B back in, what are you going to do? You're going to square it. So this is all that's important, is that B squared is 48. You can absolutely do this, and then when you plug this back in, you end up squaring it again. You end up saying 16 times 3, 48. So and when you make an equation, leave it as a square. So we've got x squared. We know our B squared was 48, plus y squared over 64 equals 1. From the vertices, or the foci, or the co-vertices, you can always find the center. The one in the middle, right? Because the center is equal distance from both set of vertices. And from both foci. or a covert. So you can always find your center and then work your way to A, B, and C. Sometimes you're given C and you have to find A or B. Sometimes you're given A and B from your diagram. You don't have to find C. You don't need it in your equation. So you guys try the next one. Sometimes you need that formula to find the missing one. So what did we get for our center?
2-1.
2-1. How'd you get 2-1? So how did you took the one in the middle, how'd you find it? What'd you do?
I just found like the midpoint.
Okay, the midpoint. So all it is the midpoint. Average of the x's, average of the y's. And the y is going to stay the same. So which one is your major axis, the x or the y? The x. The translated x is your major axis. So you know it's going to follow this format. And we know it's not a 0, 0 because it's not sitting right in the middle of my graph. So what's the value of C between the midpoint and the foci? 2. And they gave you the major axis length is 6. That means it goes 6. If this is where my ellipse goes, 6 goes from here to here. So what's half of 6? 3. That's A. This is equal like 2A, if you will. Take half. So if you come out 3, what's your vertex point? 5, 1. If you go out 3 this way, what's the vertex? Good, negative 1, 1. And your ellipse is doing something like this. Okay, now we have to find B. We know A. We don't know what B is, so use your formula. And again, all you really need is B squared. Don't square root it and then have to square it again. Just stop at the B squared. So C squared is 4. A squared is 9. Oops, sorry, 9. So subtract 9. There's your B squared. All you're going to do is plug B in and square it. So leave B squared. It makes your life a little simpler. So take your vertex now. Here's your vertex. Start like this. A is 9. A squared is 9. B squared is 5. There's your equation of your ellipse. Work with what they give you. You're going to need the formula C squared equals A squared minus B squared when you're given C and only one of A or B. But if you're given A and B, then you don't need to worry about C. It doesn't play into your formula. So kind of go by just what they give you. Determine which one is your major axis. That's where your center comes in the middle. Your foci and your vertices lie on your major.